Hi, this is Shiva Kausika from Extraleap. Extraleap Explorer is an interactive cloud-based notebook system for the developers, be it data scientists, data analysts, data engineer, whoever wants to do advanced analytics using predictive models. In this demo, we will be doing sales forecasting for a retail company operating their stores at different locations. This demo is designed for time series analysis and forecasting using seasonal ARIMA model. This process includes the sourcing of data, cleansing, exploration, feature development, building model, testing the model, finally using the model to predict the future sales. And this is how the output is going to look like. But how we got here? Let's dive into the demo. First and foremost, import all the necessary libraries here using Python interpreter. Connect to AWS S3 bucket to fetch the data that is needed to train the model and test the model. This is the stored information, and then we are getting the training information, and then the test data that we are going to use it to test the model. Now let's get into data exploration. Here we are going to check the data if there are any null data or missing data or wrong data in place. We'll be cleaning that, we'll be adding more features to it, and then further we are going to see what the data is looking like, how the sales are looking like by weekday. Most of the sales are happening during the weekends. There's below average activity during weekdays, and especially during the holidays. When there's a holiday, there's less activity or lesser sales compared to the regular days. Now further we are going to do a category based analysis, and category based on a year and promotion, 0 being no promotion, and this is the year 2021, and then followed by 2022 and 2023. On the x-axis we have month, and y-axis we have sales. You can clearly see there is a uptick or trend in sales during the end of year due to holiday season, and there is activity during the middle of year, and this look constant for the most of the stores. And over here, when there is a promotion, 0 means no promotion, 1 means there is a promotion. There is a promotion during weekdays, and that is drawing sales. When there is no promotion during weekends, there is obviously sales here. That is a positive sign. Let's further get into check the consistency of the data, and to verify that, we have picked 4 different stores, one being Seattle, another being Portland, and San Francisco and Newark. Almost the data is consistent here, and looking at there is a trend across all the stores during the end of year, and there is some data points that are higher during the middle of the year. But the New York, it's a bit different here. There is no data during July 2023 to January 2023. That's fine. We can get going. And we are going to look at the stationery of the data, especially original and rolling min. This is very much important for the time series. So we are looking at that data for all the different stores. It looks pretty much aligned, looks constant and consistent for all the different stores. And especially look at the original and rolling mean. They are pretty much aligned for all the stores here. It is good. And now let's get into seasonality check. Given that there is a trend during the end of the year and there is some trend during the middle of the year, it is important to factor in this particular trend during the model. So we are doing that check. There is a trend that is going higher in positive way for Seattle, and same for the Portland. This is different for SFO, going in down, and there is a recovery later on. For the New York, there is upside, and there is no data here in this period, so it's a flat. So now we are going to build a model. To build a model, we need 3 parameters, especially for the forecasting. That is P, Q, and D. P being order regressive terms, Q being moving average terms, and D being non-seasonal differences. So how do we get these variables for the model? So for that, we are going to look at ACF and PSCF for this 4 different stores and see, get an idea what that P and Q would look like. And we are looking at P being 2 and Q being 2. However, let's do more thorough research and get the right number that gets us too close to the accurate predictions. So how do we get that? We are going to iterate that to get a lowest AIC value. Whichever is the lowest, that combination is going to get that for us. So we got this combination, which we are going to use it and build the model. So we are building the model and fitting the model, And now we are looking at the diagnostics. If you see, the density estimator is pretty much close to NO1. This is a positive sign. That means we are going to get prediction very much close to what we are looking at. How do we know? Let's do a plot here. And over here, the actual sales is in green color and forecast is in purple color. And if you see the graphs here, the green and purple are pretty much closely aligned. That is good. This is indicating us a good start to look at that model. Things are putting in place for what we are looking at. Now let's get into the prediction for the next 3 months, and let's look at the data over here. And this would help the teams as a baseline to see what is coming for the next 3 months. Of course, we can do the prediction for next 6 months or 12 months, but a 3 month period is a good place to start with. After 3 months, we will get the fresh data, run through the same model and see what was built 3 months ago and what we have seen after 3 months, and again iterate the model. That way it would be an evolution process. Now, where do we go from here? From here, what we can do is we can run this model on a regular basis by consuming the data, and it runs on a regular basis. It can be run on once in a day or once in a month or twice in a month. You can define your own cron expression and run it. And if you're making revisions, you can maintain history by maintaining a version control. You can switch back and forth to see what has changed, how this model has been evolving over the period of time. And you can share with colleague and get the feedback and iterate through the feedback model and help the business to make right decisions using this predictive models. And this is shared with a couple of users, and now I'm going to log in as this guest user and show how it looks for the user who's just as a consumer. Now I'm logging in as guest who's a consumer of this data, and let's look at how the view is going to look like for the consumer. So for a consumer, all the controls are hidden here. To get the most updated information, you can run all the paragraphs, and once the paragraphs are run, the entire data will be updated over here, and the user can see how the progress is. So this will show if there are any. This is the legend over here. If it is in progress, if it is in running, if it is pending, that status will be reflected here. Once it is completed successfully, the user can go back to the notebook and see the updated information from here. That's all, guys. This is how Explorer Notebook platform is going to help everyone in the company use the predictive models. Here in this case, we are showing a sales forecasting using seasonal RMR model. This is not limited to this. Your data teams can import or install their own machine learning models. It can be TensorFlow, it can be another model, or it can be R program, it can be Spark program, anything as such. Anything is possible. This is an open coding platform for you to explore what is the best for your company to drive a data-driven decision in an accurate way. Thank you.